All right, good morning, everyone. So what I wanted to do was go ahead and record this Zoom video for the second part of stat homework number 3. And this is where we're looking at the regression. So I should have everything set up here to go ahead and start. I'm recording this on Friday morning, but likely not going to post it until later next week. So that ultimately you've got some time to work on this on your own and then come back and actually check the video to see if you're understanding, and if you're understanding ultimately not only the test but also how to work with either PSPP or Jamovi. So here you see the homework, just so that we are all working from the same page. Let me go over here to Canvas. I will download the PSPP file. And so there it is. And again, just so that everything is hopefully going to be working, we'll do it the old school way of going and actually finding the data so that, there we go, so that we don't have any system crashes. So if we go back and look at the instructions over here, you'll see that question 1 really is a review of the first 2 weeks of stats, asking you to describe the survey participants. So that's essentially going and looking at the frequencies and the percentages of your demographic categorical variables, as well as any sort of descriptor variable like age that is on that continuous measurement scheme. So you're going to provide the mean, the standard deviation, the median, the mode for those. The chi-square tests, totally up to you what you decide you want to run there. And then I've got 10 t-tests. And if you want to run ANOVAs in that particular instance, because then you can look at differences in race or education level. I think education level is up here. You can do that as well, because you certainly got the ability to look at gender and those that have become employed after the training. But if you want to look at ANOVAs, you can do that as well for those, for part 3 of question 1. That's asking you to do 10 tests. So ultimately, what you decide to evaluate is totally up to you. This is essentially, you are in charge of the Goodwill Job Training Program, and I'm wanting you to write sort of a report to evaluate that program based on the data that you've collected. But now what I want to do is, so question 1 is on your own. What I want to do here is look at the second component of this exercise. And this is where we're really going to be getting into the regression variables. So let's just dive right into this. And so the first part looks at, or asks us to perform a correlation between the first 10 scale variables and just ultimately discuss what relationships exist between the variables in column A through column J. And so up here, we can see that here are the questions that ultimately are asked. The program taught me new skills for the workplace, all the way down through the program made a positive difference in my life. So what I want to do is go over here to PSPP, and we can see I've already got some labels in place here. New skills all the way down through positive change. And so the first thing, again, that it's asking us to do is to come up with just a basic correlation. So in PSPP, I'm going to start with analyze. And again, I'm going down here to the bivariate correlation, because I'm asking it to ultimately compare 2 variables to each other, to correlate them, to see how they are related. And with this one, it's ultimately pretty easy. I just want to highlight everything in those first 10 variables. I'm going to make sure that it's testing the positive and negative direction, so the two-tailed, and I want to flag significant correlations. I'm going to hit OK, and it's going to show up here in my pop under window. And so here is that somewhat overwhelming table that is produced. And so just looking at this, I can already see that there are quite a few significant, statistically significant results. There are quite a few that are not as well. So I know in class we had results that mostly were statistically significant across the board. Here's kind of the first chance where we have some that are not statistically significant from what I recall. But what you want to do here, ultimately, again, we see new skills and new skills that correlates with itself. So everything, century, class. So everything down this sort of line is correlating that variable with itself. On either side of the line, above it or below it, you can essentially see that new skills and century job is the exact same results as century job and new skills. So we only have to look at half of this table, either above that line or below that line. And once we decide which ones we're going to look at, the results are going to be the same in each case. But now we have to decide in this first part, let's go back over here to the instructions. It's asking what relationships exist, okay? Well, ultimately there are relationships between every variable, okay? It may not be a strong relationship, but there is something that does exist here. Again, so that Pearson correlation value, the negative 0.46, the negative 0.18, the negative 0.09, 0.07, 0.27, all of those R values do tell us something about the relationship. So the way that I personally would interpret this result is to start to look in this area of the table to see what are my strongest relationships. And as I'm looking through the table, what I see is that here the variables I would enroll again, I think. Let me just check what this is standing for. If I were in a position to do it all over again, I would participate in the program. Okay, so I believe that's what the enroll is. And then also the program prepared me for a variety of jobs. Those two questions, or those two variables, at least on my quick glance here, appear to be the only ones that have a strong relationship by them. And if you remember in class, we talked about how -7 or lower or +7 or higher are indicative of R values that have a very strong relationship. So it appears that this 0.74, R is 0.74, P is less than 0.001 here. This appears to be the only strong relationship. The next closest one that I see, and again, there may be something hidden that in the table that I'm just not seeing or is not popping out at me, but the next one that I see, I believe, is the class size and being prepared for a 21st century job. So the size of my classes were not too large. The program taught me 21st century job skills. Those, here we get into the Pearson's R value being 0.62. Again, statistically significant. this is technically not a strong relationship. It is a moderate relationship, but that's the second highest value that I see. The way that I would report things for that first question is to find somewhere between 3 and 5 of the strongest relationships that you had. And what I would likely do here is include the 0.74 between variety and would enroll. Definitely the class size and century job, even though it's a moderate relationship, it's the next sort of highest one here. It looks like we have a negative 0.59 between positive change and classmates, a negative 0.58. Here's a 0.59 as well. So that ultimately seems to be the ones that are rising above the others in terms of the strength of that relationship based on the Pearson R value. I would simply report those and report that for the remaining relationships, either a moderate or a weak relationship ultimately existed. And so there's examples in how you would ultimately write that up over in the PowerPoint slide here. So you can see how you would write that up for that stat exercise number 3. And so let's go ahead and go back to the instructions and look at the next portion. All right, so that gets that first bullet point out of the way. So the next one's asking us to perform a regression analysis where we try to determine whether we can predict a respondent's overall enjoyment with the program, and that's in column K, using the first 10 attitudinal variables. So we're using columns A through J, which is various opinions about the program itself, to try to predict that overall satisfaction. Okay, so let's go over to PowerPoint here, and hopefully you've downloaded this so that you can also just easily use the instructions here that are provided. So let's now pop over to PSPP, and so I want to go to Analyze, and I want to go down to Regression, hit Linear Regression. And so again, if we go back and we have questions, we just want to go back and check here. The variable that's being predicted, move it to the dependent box. So again, that is going to be that overall satisfaction or enjoyment, as I've called it here in the file itself. And I'm going to use the first 10 variables. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And move those over to my independent variables. And so again, let's just go back over here. We've done that part. After selecting the statistics pop-up option, I want the coefficient, the R, and the ANOVA to all be selected. So statistics, coefficient, R, and ANOVA are all selected, so I am good to go there. And just check over here, I should be ready to go. So let's hit OK and see what is going to happen with our pop-up window, our pop-under window. All right, so let's walk through this. Okay, so a couple of things that we want to start out with. Looking at this table, let's start with looking at our R value. So R equals 0.86, and I am actually going to go over here to Word and start a new window here so that we can type this together. So what we're trying to do here is overall satisfaction equals the intercept plus something for the first 10 variables. Okay, so I'm just going to painfully go through and just go ahead and quickly write all of this up. X7 plus X8. And these 10 are just the 10 independent variables that we're trying to predict it. I know I want my R value. I know I want my R squared value, and that's how I put R squared down. Okay, so let's go back over to my results. My R value here from the model summary is 0.86. So R is 0.86, and my R squared is 0.75. And so again, this is Pearson's R. And this is where anything greater than 0.7 is a strong relationship. So we have a very strong relationship with this particular model. So again, when we try to plot this out so that we have Y being the overall satisfaction, the intercept is where we're going to be starting on that X line, and then all of these variables are plotted together. So the regression has performed the underlying statistics to figure out what mathematical formula is used to combine these 10 variables, figure out the starting point to ultimately predict the overall satisfaction. And our R squared value is really strong here. So the R squared, if you'll remember from class, this explains what percent of the variance of the Y value is explained by the formula. Okay, and so what that is saying here in this particular case is that 75%, so take 0.75, convert it to a percentage, 75% of the respondents' answers to the satisfaction question are predicted by the formula. You know, so that is ultimately a pretty strong ability to predict. So when I know how you are viewing these 10 variables, I am able to predict your level of satisfaction 3/4 of the time. So that's a pretty strong, pretty good ability to predict. Well, now let's take that information and ultimately let's go put this model together. Okay, so we're going to come back and look at the ANOVA block next, but the coefficient block here is what I ultimately need to know to be able to put that formula together. So here in PSPP, the intercept is the constant. So I'm starting out over here, and I'm just going to continue this. You know, my satisfaction, my constant, my intercept is 5.68. And then I am going to come up over here to that B column here with my unstandardized coefficients and ultimately put this formula together. So 5.68 minus 0.13 times new skills plus 0.1 times 21st century job minus 0.06 class size plus 0.27 classmates plus 0.12 facilities minus 0.07, I'm just down here, 0.07 to qualified, minus 0.02 times care, see that over here, minus 0.11 times would enroll, minus 0.17 times variety plus 0.04 times positive change. So that ultimately becomes my regression statistic, and I'm sorry, my regression formula to predict satisfaction. So I'm starting out with my constant, my intercept, starting out at that 5.68, and then ultimately going through the negative 1.3 to new skills, or 0.13 new skills there. When it says negative over here, I'm subtracting it in the formula. When it's positive over here, I'm adding it in the formula. So just sort of the basics of mathematical operations here. And so what this is saying is that I should be able to take the values that I had from my survey. If I answered everything strongly disagree, it would be 5.68 minus 0.13 times 1 plus 0.1 times 1 minus 0.06 times 1 to ultimately predict what my satisfaction score is. And looking at the full variety of responses, 75% of that time I'm going to be accurate in what somebody actually responded with that. Okay? And so when I look at this formula, I can certainly come over to the table and see that some of these are going to be more important variables than the other. And there are a couple ways to look at this. I can look over here at the beta values. So classmates is certainly the highest positive beta. Is there another high positive one? Facilities is going to be next. And then on the negative side, I've got variety and new skills. And if I go over to the statistical significance column, the p-value, I can see that there are quite a few that are statistically significant. So certainly the two that are the highest are the classmates at 0.27 with the beta of 0.27. I've also got variety there with the lowest negative beta, I guess, the negative 0.17. But I've also got new skills at negative 0.13. I got P here of being a 0.02 for 21st century job at 0.1. Here at 0.004 is facilities with a beta of 0.12. I've got my qualified at negative 0.07. It's statistically significant at less than 0.05. And also I have would enroll again. So all of those ultimately are the ones that are statistically significant and need to be reported. And so let's look at how we would ultimately go about writing that up over here in the PowerPoint slide. So This, again, is just kind of an example here from the Oakland International Film Festival. Don't want to write it up exactly for you, but what you ultimately are looking at, what are the most influential variables? So for this one, it was cost of attending and interest in volunteering. Over here in the data output, we talked about how it appears to be the classmates, okay? And so if you look back over here, I'm reporting the t-value and the p-value. So follow classmates over to the t-value, which is 5.01, and p is less than 0.001, 001. It can never theoretically be 0. So even though it says significant 0 here, significant 0, that is less than 0.001. There's just no such thing as a p-value of an absolute 0. It's non-existent. So that's my most important one, classmates. I also have variety. So here what I'm looking to do is pick out the ones that are most important. So the classmates and the variety here, because we have so many that actually are statistically significant, I might include a few more than just 2 here, but then I'm going to continue writing those things up. And so what I want to now do is finish the rest of my paragraph here. And so this is what we have used to put the formula together, my unstandardized coefficients. And if you move over here to the next part, looking at the standardized coefficients, and so that is the second column. So the unstandardized is what I'm using to put the formula together, because it gives me my intercept and then helps use those unstandardized betas to develop that formula. My standardized coefficients column over here is essentially weighting those variables if that constant is removed, is changed to a 0. Okay, so you see here the beta for the constant or the intercept is 5.68. When we're standardizing everything in our variables so that our constant becomes non-existent, what we wind up having are slight changes here. And so you can see the 0.27 rises to 0.31. The variety goes from a negative 0.17 to a negative 0.26. Slight changes on slight changes on everything. Some of the changes do appear to be a little more significant than others. And so you just want to report, again, which ones were the most efficient. And so, again, just a little bit of further way of expanding our ability to talk about the model itself. Once I talk about a couple of those, and you can see here that ultimately I am reporting the same 2 variables from the very first write-up here. In the first one, I'm talking about the t-value and its p-value for each of those variables as a result of the test of significance. And then I'm reporting sort of these standardized coefficients. When I get over to, or when I finish writing that up, I then want to talk about the R value and the R squared. And I've tried to use language here that explains what these values ultimately mean. And so again, the R value here is going to be really strong, the 0.86. And so that's a strong relationship rather than this moderate correlation here with Oakland Film Festival. The R squared is also strong at 0.75. And so that 0.75 75% of the variance in the likelihood to enroll again is explained by the 10 predictor variables that we had. Here's the line itself. So satisfaction, go back over to my Word file, satisfaction, and here's what that formula is ultimately going to look like. So that would go over here. And then I want to use the ANOVA test to determine whether or not that line is statistically significant. Let's go back over here to PSPP. And again, I am reporting my F value. The F value comes from that one-way ANOVA test. I've got my degrees of freedom here. So F of 10 and 154. So F parentheses 10 comma 154 parentheses equals 45.37, and then P is less than 0.001. So I do have a very strong model that is helping to predict someone's actual satisfaction or enjoyment with this particular training program. All right, so that gets you through the second one. I've got a lot of windows open here. All right, so let's look at this next one. Perform a regression analysis where you're trying to determine whether you can predict a respondent's likelihood of recommending the program to others based on the first 10 variables. So again, we got something pretty similar here. And so let's go back to my data. And again, going to analyze down to regression over to linear. This time, I'm using the same 10 independent variables, but I'm getting rid of enjoyment or satisfaction and replacing that with recommend. And so statistics, I've still got coefficient R and ANOVA selected. So I should be able to hit OK. And my pop under window is going to have my results for me. So let's scroll down and look at this. And I am going to work from the same file here. And what I'm going to do is just start by typing all of this out, just so you can see the process here. 7, 8, 9, and 10. I want my R value, and I want my R squared value. All right, so let's go pull some of these numbers from our table. So here's my results. So make sure you're working with the same, the right tables if you don't close the window out after each one. So my R is 0.52. So that should tell us right off that I don't have a strong relationship. I have sort of a mid-range, moderate relationship. My R squared is 0.27. So if we square 0.5 times 0.5, we're going to get somewhere around 0.27. So what this says, you know, again, this is a moderate relationship. And this is saying that 27% of the variation recommending is predicted by the 10 variables. All right, so now I need to put my formula together. And so what I've got here, recommending is, let's look at our intercept here. Our intercept, our constant, we're starting out at 8.75. That's pretty high, given that our variables all only go up to 0.9. So that should mean we've got a lot of subtracting to do to get down to where they ultimately responded. And so what we have here is minus 0.43 times new skills minus 0.21 times 21st century job. That's kind of freaky that it's 0.21 for 21st century job. Point plus 0.23 times class size minus 0.01 times classmates minus 0.18 times facilities minus 0.06 qualified plus 0.07 times care plus 0.52 times would enroll again minus 0.2 times variety. And then our last one here is minus 0.41 times positive change. All right, so there's my formula. And so I can also go ahead and pull our ANOVA results here. So the ANOVA, if you remember, is going to be F, and then essentially degrees of freedom 1, degrees of freedom 2 equals a value, and then I report the p-value. Okay, and so I can go pull that over here from our ANOVA table as well. And so I'm going to use the ANOVA portion here. So F, and my degrees of freedom is 10 and 154. So 10, 154 equals, and over here I've got 5.74. 5.74, and my p-value is, again, it cannot be 0, so my p-value is less than 0.001. So a very strong statistically significant line. So even though these may not seem to be the best results, we're predicting about 30% of the responses, which is pretty good. You know, predicting is not an easy thing to do. And so now we just need to go take this information and go write up our results. And so again, we can go over to the PowerPoint file, look at the formula here, sort of the process to write things up. I've got my key variables that I'm reporting, the ones that were the most significant. And so I can look at either the highest or lowest beta values here to determine that. When I look at the standardized coefficients, or I can look at the t values. I'm not going to report the constant because that's sort of my baseline, my starting point. So the constant is always statistically significant at the less than 0.001. But I'm looking at my 10 variables to find the highest and lowest t values. And so it looks like I've got I would enroll again, new skills, and then also positive change as being the 3 that have the most statistical significance. And so I want to take those over here, report those. If there's any that were surprising, that they were not significant. So here we have classmates, qualification of faculty, I think. We've also got care. Might decide to report those if there was something unusual or fascinating about that particular result. May include that here as well. Then I'm going to report the standardized coefficients, again, of those same variables to help highlight which ones are most important. And then I'm going to get into explaining the R value and the R squared. So the 0.52, the 0.27. And again, here's kind of where we've cut and paste or wrote everything up to help sort of explain it. The 0.52 is a moderate. It explains about 27% of the variation. And that's going to lead into the recommend plus our recommendation value equals the constant plus the 10 predictor variables here that I'm going to go and list everything out again here from my formula. And then I want to conclude with this line is statistically significant if it actually is. And in this particular case it is. And I'm going to report my ANOVA test, which we put together here and then is also again from that ANOVA table. All right, so that gets you through the first three parts of part 2. The final one, is there any correlation between an individual's overall enjoyment and recommending the program? So this is a pretty simple one, much like the very first one here, except now we're only looking at 2 variables. So let's go back to our data set. And what I want to do now is do a simple bivariate correlation. So everything that I already was using previously is still there, so I need to get rid of those 10 because what I'm looking for is the enjoyment or the satisfaction and ultimately whether or not they would recommend it. So again, I'm not testing only for a positive or a negative direction. I'm looking both directions. So I want that two-tailed and I want to flag something that is significant. And so the pop under window is going to have it over here. So scroll down and what we wind up seeing is that whether or not somebody would recommend it and whether or not they enjoyed the program are actually not related. So we have almost a non-existent relationship. So our R value is negative 0.02. And so that is nowhere near statistical significance level, since P is 0.825. And so again, what I want to do is flip back over here and then go back to look at how we want to write up our Pearson's correlation. There is a non-existent relationship, or relationship does not exist between one's willingness to recommend the Goodwill Job Training Program and their satisfaction with the program. Okay, and then you want to give that actual p-value. All right, so that is regression. I hope this was a helpful video. I'm going to send it out to you guys middle of next week or early next week so that you can use it to help you complete that second part of the assignment. So if you have questions, please let me know, and I'll see you soon. Bye.